Hello everybody, welcome to another Python tutorial. This one is a continuation of the previous one related to Google Trends with Python, although we will be creating a completely separate function, so you can follow this one even if you have not followed the one before. So what we're going to do in this tutorial is we're going to focus on the relative comparison of keywords. Using Google Trends, we do not know if the interest is high or low, we only know how it develops over time and if it's increasing or decreasing, but what we can do is we can compare different keywords to see how the interest between them compares to one another. Now in this case there would be a limit of up until 5 keywords, so you can't compare 6 or more keywords. For the purpose of this tutorial I'm going to use some activities, so cycling, skiing, swimming and diving. By the end of this tutorial, ideally we would be able to see the interest for these activities for the last 5 years, 12 months and 3 months. And we would like to show this in a nice way that the user could easily understand and make a conclusion on which activity is the most popular in that specific time frame. Now, if we want to display that, of course, we're going to import matplotlib.pyplot as plt, and this is what we're going to use during this tutorial to create our line charts or bar charts. plt.style.use. I'll set this to ggplot. It's just one line of code, and in my opinion it is worth adding it if you like the way ggplot style looks like. It makes your graphs look a bit nicer. So this function that we created before in the previous tutorial was analyzing the trends, the interest over time per keyword. We're not going to do that in this tutorial, but we can use part of the code. So if you take a look at these few lines, what we do is we build the payload, we take some keywords. This one in the previous tutorial was coming from this temporary list. In this one, it will be from all keywords, so from our initial list. Category, we won't change. Time frame, we will change as we go through the tutorial, and we're going to store that as our data. So let's go and let's start writing some code. I'll copy this part out from the previous tutorial, and I'll define a new function, relative comparison. So if you take a look at this code, what we need to change is only all keywords. That's pretty much it. Let's take a look at our data. So I'm going to run this function with only extracting the data from Google Trends just so we can see what we are dealing with. Now, if you take a look at this, what we have is we have the interest over time for these 4 activities. It is 261 rows. So we have weekly data based on the dates, so we can continue with this. Now, what we did in the previous tutorial was we would calculate the mean to get the average interest for the entire period, and that's actually quite a nice way, even in this case, to compare different keywords. So if we select, let's create a variable date mean that would be equal to data.mean. And let's take a look at how this mean looks like. So we have interest of cycling at 10, skiing at 3, swimming is the activity with the highest interest for the last 5 years of 26, but it would be much better if we have this standardized maybe from 0 to 100. So swimming would be 100, and then everything else would be related to that activity. And it will be much easier to understand what it means later on when we plot. So what we're going to do is mean, well, let's make it equal to mean divided mean.max. So what it does is it finds the keyword with the highest interest and it divides all the keywords with it. Maybe it's also good to multiply by 100, and let's round this to 2 decimals. Now, if we take a look at this, it makes a lot more sense. We have swimming at 100, so that is the activity with the highest interest. Cycling has about a bit over a third compared to swimming, and diving is about a fifth of the interest for swimming. So that's a good start. We have some data to work with. Now, how can we display this on a figure that makes sense? So this is what I want to do. First, I want to create a figure. Our figure would be equal, actually let's do it like this. Fig size equals 10 by 8. So this is the size, and we're going to show our figure so you can take a look at the empty one. Now, so far we have not plotted any data, but I mentioned at the beginning that I would like to cover 3 different periods. Now, the data that we have so far is the interest over time, so we can plot that to see how that develops over time. We can show this mean, the last part that we've created, so swimming at 100 and everything else related to that. So that is probably better to display it as a bar chart, and that means that we have a line chart and a bar chart for every time frame. So if we take a look at our figure, what we need to do is we need to divide this into 3 parts. So this would be first row related to last 5 years. First, we would have the line chart, then the bar chart. Then we would go to the second row related to the last 12 months. Last one related to the last 3 months. So let's take a look at the first row, and after that I'm quite sure that it will be much clearer to you what I'm trying to achieve in this case. So we have the data, we have calculated the mean. This is something that we're going to do for all different time frames. So let's add a comment. This is related to last 5 years. Let's start by creating our axes. So x1 and 2, what they would be equal to subplot to grid. Now, what we already mentioned, the grid would have 3 rows and 2 columns. So 3 rows because we will have 3 periods in this example, 2 columns because once we would like on one side we want to have the interest over time, and on the other side we want to have the bar chart with the interest, with the relative interest to the highest one. Now, what we would like to do is this one, it would start at row 0, column 0. So keep in mind that we have 3 rows, but they start from 0, so it's row 0, row 1 and row 2. And this particular X would span for 1 row, and column span would also be equal to 1. We can use the exact same one for AX2, except it would start 1 column to the right. Everything else remains as it is. If we run it as it is, we won't be able to, also we need to use plt.subplot to grid. So plt.subplot to grid. Let me see if we can already see some data. All right, so that looks quite good. So this is basically the position of the first row. So this is AX1, this is AX2, starting from row 0, column 0, row 0, column 1. Hope this is clear. If it's not, please let me know. And also there is a tutorial that I've created on matplotlib if you want to learn more about the library. Now let's populate these 2 axes with some data, and there's no need to print the mean anymore, so we can get rid of that part. So AX1, what we want to do is we want to plot the interest over time, and one way to do it is, well, we can have for every keyword that we have in all keywords, AX1.plot, and what we want to plot is data keyword. So as part of our data, we have the interest over time. We want to get that interest only for that keyword, and label equals to keyword. So before plotting, maybe before showing, we can also add legend so we can see how that works. And that looks already much better than before, right? We have the data in, but we also can see which line is related to which activity. And indeed, here we can see that swimming is by far the most popular one. Now, what we're going to do next is for AX2, we're going to create a bar chart. Now the question here is, what would be the position of our X ticks, and how can we change those ticks to be actually our keywords? So let's do this. Up here, I'm going to create X position. And this is just a variable that we're going to create based on the length of our keyword. So we're going to import numpy as np, and this X position, so position of the X text, would be equal to np dot arrange len of all keywords. That's it. That's all that we need. And now when we create the bar chart, what we're going to do is take the position, so it would be 0, 1, 2, and 3, because we have 4 keywords. And what we want to plot on those positions is the mean, and align it to be centered. So we take the positions that we've just generated, and we populate the data from the mean. Now, ideally, we don't want this to be 0 to 3. We want them to be the keywords. So let's take a look at the ticks and let's change them to display the keywords instead. So before showing, what we can do is plt.x ticks in brackets X position, so the position of the ticks, change them to all keywords. If we do this, that looks much better. Of course, we still need to add the title, we still need to add X and Y label, so we will get there. What I personally think would be a good option for this case, since we have 2 different types of visual representation, I would like to have one information here, so maybe we can add an X, maybe a title on the first one, so on AX1, that would be interest over time, while this one would be interest for the period, or average interest for the period. So, but we'll get there. Now what we need to do is we need to take this and create 2 more rows for 2 different time frames. We already have it for the last 5 years. And basically, maybe let's include this one here and the legends below. We can just copy this part, paste it below, and instead of having 5 years, let's have 12 months. And what are the adjustments that we need to make? So let's start from the beginning. Do we need a different parameters? Yes, we need to have a different time frame. We need to take the next one in the list, which is for 12 months. Data stays as it is. Calculating mean doesn't change. This part remains the same, so we were going to still standardize it towards the percentage. Now here we don't have AX1 and 2. In this case it would be 3 and 4. They're going to be part of the same 3x2 grid, except they're not going to start from row 0. They would start from row 1. The remaining part is the same. Next, we need to fill this with some data. So instead of AX1, we would have AX3, and instead of AX2, we would have AX4. Simple as that. With just a few small adjustments, we have added our next row, which is related to the last year. There's still some improvements. So for example, if you take a look at the dates, they're not perfect. It is something that we will change as we go on. But probably if you expand this, that's a problem that will be solved. It really depends, of course, on the purpose of how high resolution you want it to be. But for now, let's continue with this. Let's quickly create the exact same one for the last 3 months. So the last 3 months, that should be the next one in our list. So we have 5 years, 12 months, 3 months. Now here we might have another issue to solve, but let's get there and see if that's the case. Because basically, sometimes what happens is that except for the data, you also have this extra column, is partial true or false, and sometimes that might as well be calculated. If that is the case, we'll see that's something that we can solve in this part. But let's see if we face that issue. So we've adjusted the time frame. We're getting the correct data for the correct time frame. AX5, AX6, we already know that. We need to change the row, go 1 row below. Makes sense. We have our axis set correctly. Next, for all the keywords, we need to plot AX5 and AX6. And let's see if we have the issue now. Yeah, so the issue arises here for the following reason. If I comment this part out and print mean, take a look at what will happen. And this is something that we did not have in the past. We have is partial 0. And what this means is that this partial takes true or false, and it really depends on the data that you have, and sometimes it can be calculated as part of this formula, because what mean does is it calculates the mean to all columns where that is possible. And in this case that is possible, so it calculates one extra element. The way we can adjust that is, as part of our mean, we won't take all elements, except we would take from 0 until length of all keywords. And if we do that, then that is partial is not taken into account. Now if we show that, it looks much better. So we have last 5 years, we have last year, and we have the last 3 months. And of course here, for example, you can see that the date is quite it is not as good as it can be. So the last one, for sure, it should be adjusted. Now maybe one more thing, we still don't have the legends, we only have the one for the first axis. So this is something that we still need to add on the next ones. So we have AX1, 3, and 5 on the first column, and 2, 4, and 6 on the second column, or 0th and first. So we're going to add AX3 and AX5.legend. For the rest, there is no need to add additional information regarding the data, so this is quite self-explanatory. Now we have some data. You can change the position of the legend. So what I would like to do is, we're missing titles. We're missing some information that would provide us with some information. What is this that we are looking for? So what I think is a good approach for this is, we can have, let's start with AX1. We're going to set Y label last 5 years. AX3, so the next row, Y label would be last year. AX5, set Y label last 3 months. So at least one part we've covered. We know that this entire row is related to the last 5 years. This one is last year, and the last one is for the last 3 months. So we have added some additional information. We still need to add, of course, quite some more. So what we can do is, as part of the first axis, because if you take a look at the structure, we have basically 2 columns, and they start with AX1 and AX2. So if we set title on AX1 to maybe relative interest over time, and AX2 to relative interest for the period, maybe it would be good to add font size. Maybe 14 should look better. What we have is, we have some more information on what is this that we're showing. So this is the relative interest over time. This is the relative interest for the entire period of 5 years or 3 years or whatever it is that we've specified. And I think this looks a bit better. We still need to do some adjustments when it comes to the X6, especially by AX3, because I think that one, AX5, sorry, this is AX5. So this is the one that we need to adjust. So how are we going to adjust that? Well, for that purpose, what we're going to do is, we're going to import matplotlib.dates as mdates. What this allows us to do is to change the current format of the dates to one that we would prefer. So I'm going to do that only for AX5, because I think that one is the most critical one, but if you want, you can anyway do it for any ticks, any x ticks that you want. X5, we're going to use x-axis dot set underscore major formatter, and then in brackets we would have the following: mdates dot date formatter, and in brackets we specify the following. Now we have last 3 months. If I'm personally looking into the last 3 months, having date and month is sufficient. So percentage date, percentage month. Let's see if that looks better. All right, I think that's quite acceptable. The year is not, I don't think it would add any value in this case, because it's clear that it's the last 3 months. So that's quite sufficient. If you want, you can always add the year with the same approach. For the purpose of this tutorial, I would say this is sufficient. You can always change. Of course, this one is if you want year then month, or month and then followed by the year, you can do that. But I think this is quite a good approach, and we have quite a nice representation, so a relative comparison between different words. And what you can do now is, well, just use different keywords to compare different stuff. So maybe you would like to take a look at Samsung compared to Apple, and maybe compared to Huawei. You can do that. If you just change the keywords, everything else the same, you can clearly see that, for example, okay, Samsung seems the most popular worldwide because geographically we have not selected any region or any state or any country. But maybe you would like to take a look at these particular keywords for US. If that's what you want to do, then maybe the outcome would be completely different. So as you can see, the interest over time is different. Apple is, in this case, the most popular one out between those three. So maybe you would like to calculate interest between different sports. Maybe you would like to calculate Cristiano Ronaldo compared to Lionel Messi, and then you would get a comparison on that. Now keep in mind that at the moment this is in US, so maybe we can, let's take a look at that first. So this is the interest based on Google search for the two athletes. You can choose different region, you can choose states. It's really quite flexible once you have this part done. And don't forget, you can always combine the two. So I'm going to take this part that we've done in the previous tutorial, add it down here. And if we run both, so if we run the check trends and relative comparison, maybe let's use the following. Let's use beer and wine. There is always a debate on which one is more popular. So let's combine these two and see how that looks like. So we have the following. This is the information regarding the trend. So you can see some information as a conclusion, and you can always have the graphical representation. Now based on this, you can clearly see that wine is more popular. But if you take a look at this one, you will see that the interest for beer is actually more stable. So one is being more popular compared to the other, but the other one is being more stable, less volatile compared to the other one. So this is how you would go into using these different, at least for now, two functions to analyze different keywords. It's really quite flexible, but don't forget, analyzing individual keywords, you won't have a limit of 5 keywords in the list. If you use this relative comparison that we've just created, there is a limit of up to 5 keywords. Just keep that in mind. And I hope that this is clear. If it's not, please let me know in the comment section below, and I'll see you in the next tutorial. Actually, you'll see me in the next tutorial. Thank you for watching, and until next time.